Today I will talk about Kaplan Meier Curve. It is one of my three lectures on survival analysis. This is my lecture outline. First, I will talk about survival analysis in general. What are the three methods of survival analysis? Then I will give introduction of Kaplan Meier estimate. Then I will talk about assumptions. Then I will talk about survival probability formula. Then I'll talk about survival probability curve or Kaplan Meier curve. And then I will state a Python code using one of the Python package. So there are three survival analysis. One is Kaplan Meier estimate. It is also known as the product limit estimator, and it is a non-parametric statistic. Second is log rank test. Kaplan Meier estimate can be calculated for two groups of subjects, and their statistical difference in survival may be calculated using log rank test. Then Cox proportional hazard model. Multifactorial analysis to study the effect of more than one variable on survival may also be done using Cox proportional hazard model. So this lecture is on Kaplan Meier estimate, and there are two other lectures on log rank test and Cox proportional hazard model. In clinical trials or community trials, the effect of an intervention is assessed by measuring the number of subjects survived or saved after that intervention over a period of time. Where an event can even be a specific outcome other than survival. For example, time it takes for a couple to conceive. The time starting from a defined point to the occurrence of a given event, for example, death, is called as survival time. And the analysis of group data is known as survival analysis. One of the example is survival time of patients after modified radical mastectomy in case of breast cancer. Survival data is usually right censored, and right censoring occurs when subjects under study that are uncooperative and refuse to be remained in the study. So these subjects leave without an event happen to them. When we lose touch with them midway in the study, so these are lost to follow-up patients or subjects. When some of the subjects may not experience the event or death before the end of the study. So these are the reasons of right censoring. Sometimes there is left censoring also. Then Kaplan Meier's estimate. In 1958, Edward L. Kaplan and Paul Meier collaborated to publish a paper on how to deal with censored observations, as we have seen right censored data. Kaplan Meier estimate is one of the best options to be used to measure the fraction of subjects living for a certain amount of time after treatment, as we have seen in example of breast cancer. It involves computing the probabilities of occurrence of event at a certain point of time and multiplying these successive probabilities by earlier computed probabilities to get the final estimate. This I will explain soon. The Kaplan Meier estimate is also known as product limit estimate, as we have seen in my previous slide. The Kaplan Meier survival curve is defined as the probability of surviving in a given length of time while considering time in many small intervals. And Kaplan Meier analysis is also used in non-medical disciplines. For example, length of time people remain unemployed after job loss. Another example is the time to failure of machine parts. Another is how long fleshy fruits remain on plants before they are removed. This is the concept of serial time. So, after the start of observation of a particular individual till an event which happened or censoring whichever occur earlier is known as serial time. So this is the serial time of a patient who survived for longer duration. This is a serial time for patients who survived for shorter duration. And this is end of the study period. If event does not happen till this time, then there is censoring of data. In preparing Kaplan Meier survival analysis, each subject is characterized by three variables. Their serial time, as we have seen this concept of serial time here. I have taken this from article. Their status at the end of their serial time, whether an event occurred, for example, death, or it is a censored data. And the third is the study group in which they are in. So these are the three variables. To generate a Kaplan Meier estimator, at least first two pieces of data are required for each patient, for each subject. So first two, these two. However, if survival function between two or more groups are to be compared, then a third piece of data is required, the third one. Then assumptions. We assume that the event happens at the time specified. This requires regular follow-up at smaller intervals. So regular follow-up at smaller intervals is required in the analysis. We assume that survival probabilities are the same for subject recruited early and late in the study. We assume that at any time, patients who are censored have the same survival prospects as those who continue to be followed. So these are the three assumptions of survival analysis in general. Then survival probability formula. For each time interval, survival probability is calculated as the number of subjects surviving divided by the number of patients at risk. Subjects who have died, dropped out, or moved out are not counted as at risk. That is, subjects who are lost are considered censored and are not counted in the denominator. Total probability of survival till a time interval is calculated by multiplying all the probability of survival at all time interval preceding that time. This is because of application of law of multiplication of probability to calculate cumulative probability. For example, the probability of a patient surviving 2 years after a modified radical mastectomy can be considered to be probability of surviving the first year multiplied by the probability of surviving the second year, given that patient survived the first year, and hence the second probability is known as conditional probability. And our assumption is that the probabilities of first year and second year are independent. This was our assumption. The estimator of the survival function ST is given by this formula I have taken from this site, where time Ti when at least one event happened, and Di is the number of events, example deaths that happened at time Ti, and Ni individuals known to have survived up to time Ti. So they are at risk individuals. More generally, for continuous as well as discrete survival distribution, Kaplan Meier estimator may be interpreted as non-parametric maximum likelihood estimator, because this is likelihood estimator of our survival probability function. This is log likelihood, and we equate it to 0 to get maximum likelihood estimator. So we get a hazard function as this. So this is the survival function. Variance, there are few different methods to calculate variance of Kaplan Meier estimator, and one of the common method used is Greenwood's formula, and this is the formula I have taken from this side. Then survival probability curve. A plot of the Kaplan Meier estimator is a series of declining horizontal steps like these. This is of group 1, this is of group 2. On the plot, small vertical tick marks state individual patients whose survival time have been right censored. Sometimes there are vertical marks, tick marks on this curve. I have taken this figure from this article. Now let us see Python code. I have copied the Python code as described in internet from the documentation of package lifeline. So we will use the package lifeline for Kaplan Meier estimator. So this is the import. Then we will use the inbuilt or inherent data set in the package lifeline. So this is the data set. We have a timestamp and we have the event stamp, which is either 0 or 1, and we have a third variable as group. As we have seen, there is requirement of 3 variables. And for Kaplan Meier, we will use only first two. So this is the code we are using first two variables to get the Kaplan Meier curve. Then this is the code for survival time. It is 56 years in our present data set. So this is all for today. Thank you very much.